All right. Let me give you a problem. Okay. And this is a problem. So you have a body which is moving like this. Okay. It is at point A, and the A coordinates are 5, comma 7. Then it moves to another point B. Okay. We don't know what is the position vector of B,
Okay.
right? But we know the initial position vector as OA. From A it went to B. We know the position vector of B. The question is, what should be its displacement after B so that its net displacement becomes 0. So from A it moved to B.
Yeah.
We have no clue what that B is. And the question is, from B, what vector do I need to add from B so that it reaches back to the 0 displacement point? Which means what? It started from A and it should reach back to A. This is its initial point, right?
Yeah.
This is its initial position. Then it reached B. The question is, what should be the displacement that should be added so that the net displacement it exhibits becomes 0? Which means if it was at some point B, then how it should move so that it reaches back to the point A? What will be that vector looking like? And we know the point B is, for example, hypothetically, it is located here. Right? So we know O and we know B, this is A. The question is, how should now I move from B to A? What that vector should represent? And of course, if you look into the diagram will give you a hint that the vector is actually starting from B and going back to A. If you do like this, if you show this displacement, then your net displacement from initial and final perspective will become 0. Agreed?
0. Yeah.
Now you know the two position vectors. First, calculate when you moved from A to B, what was your displacement. First, calculate how much did you actually move, right? You need to find that. And then only you can decide what to do with that to make it 0. So first decide how much movement was there or displacement was there from A to B.
Y vector.
Now you know the concept of position vectors. What is 7?
7. 7I.
5i. The I is
Yeah.
always with the x.
Oh, sorry. J.
And what are you writing? The OA. Which
No.
vector are you writing?
OB. AB, right?
No, AB is to be
The
found out.
distance.
How will you find it without knowing the position vectors? You just learned what are position vectors. You know the
Right.
position at A and you know the position at B. First write the position. What was it? Initial position. OA. Where have you written it?
5I plus J
Correct.
caps. And
Correct.
OB
What is
is.
OB? That's your final, right?
Yeah.
Okay. Agreed. What is your displacement from A to B?
A to B. It should be subtracted
Yes. Final minus
5.
initial.
So, wait, let me. I should be A, right? Because
What is
final
final?
minus.
What is B? Final minus
B is the
initial.
final. Yeah,
Where is the final? Where have you written final? What
it
is
should
this?
be B.
Please rewrite it. It's not clear. Yeah.
Yeah, yeah.
Write it neatly.
Final displacement.
Net displacement, not final displacement. Net
Okay,
displacement. It's your net, right? Net of movement. So net displacement, yes, is
is BA.
you need to write in terms of, yeah, okay, it's B. It's actually, yeah, BA. Okay, let's call it BA.
So yeah, the
When you
in
move from
terms
A
of
to B, when you move from A to B, I will write it as AB. This shows you moved from B to A. AB shows you moved from A to B.
A to B.
This is wrong. It should be AB.
Oh, okay. Oh, I thought you drew the
No,
arrow like
my
this.
question was, what should we do to go back to the same position? How much displacement do I need
Okay,
to do?
to B. All right, I
Yes.
got it. AB.
First, at least move from A to B.
Okay, okay.
What is BAB? Okay, yeah. Now do it properly.
It should be the final minus initial. So, but we have to do from the vector. So it should be they give AB 0, right? Yeah. 0 is equals to
Don't worry about it. First, find the displacement from A to B. That's all. Then we will worry about what is to be done with that. First, we are calculating how much you actually moved. That's
it
the
should
first
be
part.
y minus 7. No, y plus 7 minus x plus 5.
I think I told you how to find out AB. It was straightforward. The position vector of B, which is final position vector, which tells you the final
Subtracted
by the
from, oh
initial
yeah,
position vector.
right. So it should be wait, y OB. Okay.
What is this O?
X.
What is O?
It's 0. AB, they gave the final displacement
Don't
should
worry
be
about
0.
it. First, you have to calculate what is the displacement that happened. If you've
Okay.
written AB, then put it as AB first. Calculate
Okay.
AB, then worry about the logic. First, write the vector which represents your displacement.
Okay. X plus Y. I don't need to write the I and J, right?
You for a vector always.
Oh, okay.
Okay. Collect all the i's. Take I common.
I should take a common. Okay. Uh, wait, common? I'll just do it like this.
X minus 5 in the bracket.
Yeah, I'm gonna do that. X minus uh, this side.
Correct. J. Right.
Yeah. It should be this.
Yes. So this is your displacement, right?
Yeah. I- Okay.
This is the net displacement you exhibited. Now let's go to the question. We want to do one
I
more
was, I
displace.
was, okay.
Allow me to complete my sentence, please. I am writing my displacement, right? This is the amount of displacement I've already done. Yes, agreed?
Yeah.
I'm saying please do another displacement which we don't know of so that
Okay.
the net displacement becomes zero.
0.
So let the vector that represents that displacement be a vector x. So you are doing x displacement, we don't know how much, which will make the net displacement to be zero. Now substitute the equation, the value of displacement you got in this equation. And so this is the logic you were trying to apply earlier, right? I am telling you steps how to write it in an
Right.
examination.
Okay. Okay.
You- So if you do this much displacement, after the first displacement, you will finally end up at zero displacement, which means back to point A.
Right. Like it just, is this is equals to, okay.
Minus, yes, you're right, minus AB.
X minus 5
What is this sign? I'm not able to. What is this sign?
is equals, is equals to,
Okay, so you're taking it on the
sorry.
other side. Okay,
Yeah, transposed
agreed,
it.
agreed.
Minus I
Hmm.
plus
Hmm. Excellent, good job.
minus.
Won't this also become negative? So you've
Which
taken the
one?
complete negative.
I've
You've
taken
taken
it
this.
common.
Okay,
Yeah,
please write the brackets properly.
right. I can, okay, yeah.
What are you doing now? What is
I
this?
can open the bracket.
No, there
X,
is no need
X.
to open.
Okay, I
Where is
don't
the
need to
other
open it.
x? Which XX are you referring to?
ये वाला.
This is capital. This is the net displacement,
Right,
what you
right.
were supposed to
I
find.
changed it.
And this is the coordinate. It has nothing to do with x. I can name it as a P. Why do you care about it? Name it anything you want to. But
Yeah,
it
I'll
has
let
nothing
it
to
be.
do with this x.
Yeah, yeah, I know.
Okay.
I'll just let it be P. Okay.
Hmm. Hmm.
Uh, minus X.
You can leave it here. I mean, you can just leave it like this.
Okay, I
If
can.
you if you
Okay.
bring if you bring a minus sign inside, the worst that will happen is 5 minus
Minus.
x. The signs will get reversed because a minus sign
Yeah,
entered, right? That's a struggle.
J. Yeah,
Got it?
yeah, yeah.
So if you move this much, which means you actually do reverse walking like this,
Right.
go back to the same place. This is a vector that represents the going back. The P vector is the vector that represents. So if AB represented one way, two, then the fro is this, right? To and fro. So you started from A, went to B, took a negative of the same vector, and you're back. You have just taken the negative of the displacement. And which
Right.
is something very close to the example you gave. You throw a body upwards, it comes down, the displacement is zero, right? Which means whatever is a vector reverse of that vector, right? With a negative sign. If this vector was 5j, then you travel minus 5j, put a negative sign, your displacement will become zero, right? And this is what you have
Right.
done here also. You put a negative sign in front of AB here,
AB.
and you got your
Yeah,
vector, which means you're going back wherever you
right.
started from, right? But remember, your initial strategy to solve the question has to be position vector.
Okay,
Use of position vector is more important than just calculating this. Let me give you
okay,
one more exercise to do so that let's see if you're able to solve it. Okay. Now this time there is a body which is moving like this. Okay. And I will give you its position is P and is represented by 3 comma 3. And then you reach here, which is 5 comma 7. And then you reach the point C. Okay. So this is A, this is B, and C. So the C vector, the position vector of C is given to be xi plus yj, which is the position vector of C. Okay, so this is OC. What should be the value of x and y? What should be the value of x and y if BC is equal to twice of AB, given x is equal to 3 times y? These are the two conditions you are given.
okay.
BC should be double of AB and x is equal to 3y. Condition number 1, condition number 2. You know the coordinates of A, B, and C.
A, A, B.
So this was a car which was moving around. Okay, fair enough. Don't worry about the straight line, it's okay. We can always use this
Real
line, right?
life.
Two lines. Okay, let's
Okay.
say this is AB, and then you want to show another one which is BC, right? All right, done, done. Now you to write. First, you need to find the vector BC and
AB.
then AB.
Okay.
You can whichever you like, whichever you like.
We can do BC
Please use
first.
position vector. You have not written position vector of anyone. First, you will write the
Alright.
position vector. We are studying position vector. Just write it straight away.
Okay, I can write it. Okay.
Yes, you can. You're writing OA, right?
Yeah, OA
Exactly.
first.
Write all first. But get this right in your head that you will use the concept of position vector.
Position vector.
Very important to understand. OA. Okay.
These are both 3, right?
Yes, these are 3. 3i plus 3j. Because I am also making you practice the vectors also with this. Vector addition. Good. Once you get your vectors right, a lot of physics becomes easy for you. Excellent.
Right.
Now you're getting proficient. OC. Excellent. Agreed. Okay. Now you will find the BC vector. Find the BC vector
So BC vector.
using the
B.
position vectors. So you
Yeah,
move from
BC
B
should
to
be
C. The final position
B.
is what? In
OB.
BC, what is it? No, I don't
Oh,
think
C,
so.
C, C.
Correct. So it is going to be OC minus OB. Correct. Good. Okay. Solve it. solve it if you directly, just see the numbers and subtract them. Yes, so x minus 3i, this is x,
Okay.
this is 3, x minus 3i.
No, this is OA. It should be 5,
Yeah, okay,
right?
x minus 5, correct.
Yeah.
Correct.
Minus 5i
Hmm.
plus y minus 7j.
Agreed. So let's say these are in meters. Okay, done. Not bad.
Okay.
This is also meters. This is
Right.
also meter. This is all are meters. Okay, no problem.
Right.
Go ahead.
And now AB.
A B.
B is OB.
Yes. Now you got
Minus.
the logic right. Finally. Now you've started doing it fluently.
Right.
Doing it fluently now.
I'll just write it directly. OB minus OA is 5432.
Yes. So it
I
is.
minus. I can just 1 minute.
Just be very careful when you're subtracting. That's all.
Yeah.
You can. 5 minus 3 is 2, correct? And 7 minus 3 is 4. Very
Yeah.
nice. Good job done. Now you're getting faster. Okay.
Right.
Hey, just tell me, why have you written minus here? So OB minus OB was how much? Why there is a minus sign? Can you explain that?
Like the formula. So when we open the bracket.
No, so first you're
Like-
subtracting x, right? You subtracted
Yeah.
the 2x.
Yeah,
What
yeah.
did you get? 5
Okay, I can
minus 3.
directly write it. Right.
Yes, you got the mistake also.
Yeah,
Excellent.
I got it.
Well
I got
done.
it.
Well done. Now your work is cleaner because your mind is cleaner.
Right. I'll just substitute. So x
Hmm.
I J.
Very nice. Okay. Ignore this for a while. Okay. Continue to do that, then I will tell you. Okay. Okay. Ignore this for a while, given this. First, let's solve this. Let's solve this.
This?
Yeah,
Only
this.
okay.
Don't
Okay,
worry
okay,
about don't worry about that condition for a while.
Okay.
Okay.
This is
Now what?
4i plus 8j.
Yes.
Uh,
So now
I should
compare
have
both
opened-
the sides. Compare both the sides.
Let me just. Okay.
Now
X
compare
minus
I
5.
huh,
X minus
minus
5
5 is equal to 4. Very nice. Great job.
Y minus 7
Great job
is
done.
8.
Yes. So x is equal to
3y.
no, don't put it. Don't
Okay,
put
okay.
it. No need. No need. So this is to be ignored totally. Please ignore this
Okay.
condition. There is no need of using this. I was just
Okay.
trying to establish a quadratic, but I think this is a linear answer. Okay. So we will ignore that part. Don't worry. You got it. Right. So what is the
X.
value of x and y? You got the answer.
9 and 50. Yeah.
Answer. So which means if you were to write the position vector OC, what it will look like? Right. Final question is, what is the position vector of C? What is OC going to look like?
9i plus 15j.
Excellent work done. This is very nice work done. Fantastic.
Right.
Now you got in your head because you've already done this in class 11. You're just brushing up, right? You're able to
Right.
recall what you've already forgotten. You're recalling it now. Okay.
Yeah.
Good job done. I think you were very methodical, you were very logical, and you got the point that position vector is the central idea we are trying to learn from this, right? We are doing kinematics because we are dealing with physical quantities like displacement and all that, but we're also simultaneously learning how to calculate something like a displacement using the concept of position vector. Very, very important for you. Okay. Let me just
Okay.
continue the discussion. Let's take a 2 minute break. Okay. Take a 2 minute break, have some water, take rest, and let's
Okay.
be back. Okay.
Okay.
Let's make it 5 minutes. It's
Okay.
3:15
Okay. Thank
India
you.
time. I think it's your time 11:15, right?
No, it's 10:45.
10:45. Let's meet in 5 minutes at 10:50 your time.
Okay.
Take a
Okay.
break.
Thank
All
you.
right. Let's come back. Thank you. All right, I'm back.
Yes.
Can we start?
Yes. Yeah.
You earned the break. I gave you the break.
Yeah.
You did good job. I think I really liked it. It was pretty neatly done. Like clarity was there. All right. Since we're talking about speed, one of the very good questions that comes on this topic and as a concept you should be aware of is the concept of different types of speeds that you will see. Okay. And let me do one thing. I'm adding a page. Okay. And you
Okay.
can see it. Or I'll do one thing since I'm explaining you something. Let me share the screen with you. Tell me once it is visible. Visible?
Yeah, I can see.
You can see, right? Okay. I know it's an uphill task to try and do 2 year course in one, but it is doable by the way, just because of the willpower. You can. All right. Let's talk
Right.
about different type of speed. So one is of course the speed which you have already done. Speed simplest is known as distance upon time, right? Let's talk about other types of speed. So the first speed I'm going to talk about, which is the one which must know. So you can have different type of motions, okay, and that will decide what type of speed you have. So for example, you have a uniform speed, okay, which means you will cover equal distance in equal time intervals. The words uniform speed tell their story. Look at the
Yeah.
second one. Okay, the second one is non-uniform speed. There is no uniformity. You can cover whatever distance you want to in equal amount of interval. So unequal distance in equal time interval. Let's talk about third, which is the average, right? The average speed, how do you go about the average speed is you calculate the total distance in your journey
Right.
and divide it by the total time. So the one which you need to really understand is the average speed. And let me explain you what happens in the case of average speed. So I'm just talking about average speed now. This is self-explanatory. You are 20 meter per second everywhere you go. You're 20 meter per second, 20, 20, 20, 20, 20, right?
Right.
Non-uniform means you go like this 20, 30, 40, 50, 60. There is no uniformity, but the time interval which you're referring to is same. It is 1 second here, 1 second here, 1 second here, 1 second. So which means you're traveling unequal distance in equal times, right?
Right.
So that makes you non-uniform. The time given to you is same, but the distances are different. Let's talk about the most important one, which is the average speed. Right? Let's talk about average speed. I will show you a linear motion in x-axis and just see it very carefully. You start from A, you travel to B. Your velocity during this motion is v1. The time you have taken is t1 and the distance you have covered is s1. From A to B, your velocity was v1 always. Then you move from B to C, your velocity is v2, the time you've taken is t2, and the distance traveled is t2. Then you move from C to D, it's v3, t3, s3. Okay?
Okay.
Now, somebody said, I want to understand your motion. What the hell are you trying to do? I want to understand this big motion of yours, starting from A to D. Tell me On an average, what's your velocity? I don't want to get into nitty-gritties of individual parts of the motion. Broadly, tell me, when you started from your home and you reached my home, what's the average speed you had? A lot of people discuss averages, right?
Right.
In life. I mean, don't get into detail. I went from A to B, then from B to C, then C to D. I got
Correctly, A
this.
to D.
Yeah, I don't want to listen to that. Just tell me on an average what happened, right? Let's see what happened on an average. Now we know the speed throughout A to B was V1. From B to C, it was V2. And from C to D, it was V3. So you have three parts of the motion. Each one is uniform in itself, but at a big picture level, it's not uniform because your velocity or speed in in the respective portion is different. So to an extent, you're also non-uniform. When you're
Okay.
non-uniform, you still have a opportunity to tell the big picture story, which is the average of the whole motion. Now, let's talk about the average of the whole motion. When I am discussing the motion in AB, can I write S1, the distance covered, is equal to T1 multiplied by V1? Where does it come from? Speed is given by distance upon time. This is something we learned in class 9th. Right? Let's
Right.
talk about BC. BC,
Yeah.
the velocity is S2 by T2. By the way, if a motion is a linear motion in only one dimension, x-axis, then distance is equal to displacement.
Displacement. Yeah.
You read this in class 9th also. Generally, distance is greater than equal to displacement, because distance is the actual path, whereas displacement is a straight. So the sum of all these will always be greater than the displacement, which is a direct line. You can go from here to here directly, right? Now add these. These are the distances, right? If you add them, the sum of all this will be greater than this. So generally, distance is greater than equal to displacement. The shortest distance will be your displacement. If I am moving in a straight line, my speed magnitude and my velocity magnitude is also same, because I'm in only one direction. I'm not changing my direction, right? I'm going in one direction. We will come to some of the exceptions to this, but broadly, if I use the word speed and velocity in one dimension, don't worry about it. I'm going in a straight line without turning, right? I'm just going in a straight line, and I'm also not coming back. If I come back, my displacement will reduce, right? So which will come to later. But let's talk about, we are moving forward. We're not coming back. We're moving from A to B, B to C, C to D. Let's calculate V3 is equal to S3 by T3. From here, can we write the distance and the displacement are one and the same thing, because it's a straight line from B to C? Whatever distance you have cleared is same as the displacement in BC. One and the same thing.
Right.
I'm from here to here, right? B to C. What's my distance? B to C, BC. What's my displacement? BC. Both equal. Special case, because I'm not going like this, which is when my distance becomes greater than displacement. So, all right, you get the point. So S2 is equal to V2 into T2, and therefore S3 is equal to V3 into T3. In the three parts of the motion you saw, A, B, B, C, C, D, you also notice that they have traveled their individual distances oblique displacement, one and the same thing. Let's calculate the total distance, because average means the total distance has to be calculated. Let's calculate the total distance. Right, which is S1 plus S2 plus S3. What is the total time? You get this point?
Yeah.
All right. Any questions? Feel free to ask. I have just calculated the total distance. Yeah, this is what I've done. average.
Yeah.
Total distance upon total time. I've done nothing exceptional. Okay. Okay, all right. So let me do one thing. So
Okay.
this is V1 T1 plus V2 T2 plus V3 T3 divided by T1 plus T2 plus T3. This is my what?
Total
V average.
average. Yeah. Okay.
Total distance upon total. This is one way of looking at it. A lot of
Okay.
people don't want to write this thing. The so what they do is they just write the distance in the numerator, which is s1 plus s2, one and the same thing. I mean, it depends how you want to write it. Some people may write it like this, and they express the time in terms of s and t. So I will get the time from here. My time will look like S1 by V1 plus S2 by V2 plus S3 by V3. It is purely your choice how you want to write, because you have three variables to play with. You need to write in the numerator total distance, which you can, depends on what is given in the question, and divided with the total time,
Okay.
and you get the average. Now, in one of the questions, it was given that although the body travels equal distance in respective time interval. So in the first time interval, it travels s. In the second time interval, also it travels s, and in the third time interval, it also travels s. Which means maybe first 10 seconds it was able to move s. In the next 20 seconds also it moved s, and in 30 seconds it moved s. Different time intervals, but different.
Same
Exactly, right? So
distance.
let's see what happens if we do this. Okay, let's see that now. Something
Same
magical is
distance.
going to happen.
Okay.
I'm going to
Okay.
put all of these as s plus s plus s divided by s upon v1 plus s upon v2 plus s upon v3. Can you see s will get cancelled because it is common
Right.
in the numerator and the denominator? Okay, so this will be 1 by v1 plus 1 by v2 plus 1 by v3. Is s gets cancelled there? Can you see this?
Yeah. 3 by
And you get 3
3 into V1
v1
plus V2.
v2 v3,
Okay.
the
V3.
LCM,
Okay.
and in the denominator you get
V1, V2, V3.
v2 v3 plus v1 v3 plus v1
V2,
v2.
V2.
This is the answer you get.
Okay. Got it.
Understood? So the concept of average velocity is very important. You do, in most of the examinations, they expect that you understand that the big picture is reduced to a common number, and you can tell the people, this is my average. That's the way you can look at the motion. So you don't get into the details of the motion. Instead, you get into a big picture of the motion. Made sense?
Yes.
Okay. Now let's talk about what I was referring to as, let me get into details of displacement, and this is important to understand because now we know there's something called as average speed and stuff like that, which is good.
Right.
We solved a numerical also. Let's see See, sometimes what happens, I also mentioned that generally you will find distance to be greater than equal to displacement. In the worst possible scenario, you will have distance to be equal to in a straight line motion. Specifically, if you are just going straight and there is no turning back, you will have distance and displacement
Equal.
always equal, which is what we studied in class 9th also, right? Now let's take a question where you have this as your origin. This is your, so you start, you move here, you reach here. It takes you 10 seconds to cover OA, which is equal to 10 meters. And what you take to cover all of this is 5 seconds. Okay? Then from A, you turn back now. This is a change. We're turning back. We're going back. When we go back, this is where we reach. So we reach at, 6, comma 0. Okay? And we took another maybe 2 seconds to do so. My question to you is, what is my average speed? And also tell me what is my average velocity. Remember, I told you speed and velocity are same only when you're not turning back. If you're turning back, they're not same. Now the question is on understanding of the concept of average speed versus average velocity through this example. What do you think is the average speed? Total distance.
Okay, total distance by total time.
Total time, no big deal. What is the total distance you have covered? First you went to A. How much distance did you cover?
50. Oh, okay, it's 10. Okay.
Where did you see 50? Nowhere.
What is this? No,
This
what
point?
is this? No, this.
Okay, so you reached back this point.
Is this
B.
not 5?
This is 6, comma 0.
Okay.
Got it? Understood?
Wait, once,
All right.
1 minute. Yeah.
Now tell me,
Okay, it's 6. Okay.
What's the other distance you have covered?
6 meters.
No.
Backwards.
No. You were at 10, comma 0 and you reached 6, comma 0. So you have only covered 4 from 10 to 6.
4. Yeah, from 10 to 6.
Makes sense?
Yeah, that's what I meant.
Yeah. Yes.
Yeah.
Agreed. What is the total time you have taken to do all of this? O to A to B?
O to A is 5. And 5 plus 6, 7. Yeah, total is 7. 14 by 7, okay, 2. That's the average speed, 2 meters per second.
Right?
Yeah.
Pretty cool, right? I mean, total distance about it. Total time, what's a big deal, right? So you can tell someone my average through this whole journey was, and you actually had no concept of vector in this. Everything was a number. Now when you talk about average velocity, velocity on the contrary gives is all about final position minus initial position, which is displacement upon total time.
Yeah.
Okay, so this is going to be displacement upon total time. Tell me the displacement.
4.
4. You started from here.
Yeah.
And you ended here.
The 5. Right. So, okay.
This is your X
yeah, the
initial.
total is 10.
And this is your X final.
Right, it should be 6. 6. Yeah, 6.
Correct. And total time is still the same.
Right.
Look at the
Right.
difference.
Okay.
One is
Got it.
one guy saying 2 meter per second, the other guy is saying 6/7.
Right.
This is also very
Got it.
important to understand. The concept of average velocity, always, irrespective of the motion you see, uniform, non-uniform, and all that, only deals with this thing. And this is very important to understand. XF minus X initial upon the total time of travel, T travel,
Yeah. Got it.
is V average. But the V speed only deals with sum of all the distances. 10 distances divided by 10 times, whatever their values are. S1 till S10, if there are 10 distances, divided by respective time intervals.
Okay.
Way too different. One is just a number addition and normal average. The other is you
Displacement.
exactly. And now let me graphically tell you what happens. So
Okay.
this is your XY coordinate. What you do is you move around in like this. Okay, so first you go like this, and then you go like this, then you go like this, and you end here.
Right.
So if you were to do a distance calculation, you will actually measure in your car how much distance have you covered, right? Then you stopped
Yeah.
there. Then you took rest. Then you went ahead, and in your car the reading is 50 kilometers, and the total time including the rest is 30 minutes.
Right.
Total distance upon total time. So 50, convert this to half an hour. So this is your average speed was 100 kilometer per hour. This is 1/2, right? Half an hour.
Right.
So 50 divided by half is equal to 50 into 2.
Right. 100.
But now somebody said, I'm not interested in this. I want to know your car reading is giving some information very, very good. Your average was 100, but tell me from physics point of view, which is as the crow flies, what's your displacement? So he said, okay, I can tell you the displacement only when you tell me where did you land up. He said, we have landed up at, as the crow flies, at 20 kilometers away, direct. If you were to go direct, maybe this was a river which you could cross, but you did not. Instead, you chose a car, right? Now, the river displacement is 20 from your home, but the time is
Right.
again half an hour. So it is 40 kilometers
40.
per hour.
Yes.
The point is
Got
not
it.
that this is repetition of what I've already said. The point I'm trying to make, the average velocity does not care about what happened during the motion. It is only worried about the initial and the final. Whatever you do, you can just do anything you want to do in middle of these 2 points, which is the initial position and the final part. Do anything you want to do. Go ahead. We will not give a damn to it. We don't care about what you did. We just want this. XF minus XI divided by total time. And there you go. You have your answer. So average velocity is a way of looking at the motion without worrying about what's going on. But the average speed still worries about what's going on, right? It actually takes care into the whole distance, everything.
Right.
V average does not. V average just gives a bird's eye view. You were here, and that's about it. What happened in middle of the whole journey? None of my business. You took a rest, you stopped there, we don't give a damn. Tell us where you are, divide by the time elapsed, and you get your answer.
Okay.
Right. So much for the day today. I think we'll bring this to a halt now, and we will meet
Okay.
shortly for our next class. Okay.
Okay.
Let's fix up the time in the coming week so that we stay in touch and
Right. It's
continue to make
tomorrow.
progress. Let's meet tomorrow then. But we'll have
Yeah.
to. I will get free at around 10 p.m. India time.
Oh, then that's okay.
So that means it is
6:30.
your what? Your 6 p.m.
Yeah.
We can meet for 1 hour.
6:30. Yeah.
Yeah, we can
Yeah.
meet
Yeah.
for one
Sure.
hour.
Sure. Sure.
Let's meet tomorrow and do 12th standard now, which is continue to have discussions of electrostatics. We have done till the infinitely charged linear charge density continuous one with the lambda. Now we will do the infinite sheet. That's our next discussion due tomorrow.
Okay.
If you can spare time, we can meet because you're on a different time zone. But if we keep on talking to each other, we can decide on some times where we can meet more frequently. It doesn't matter. Maybe for a shorter
Okay.
duration, maybe not for 90 minutes, maybe for 45 minutes, maybe for 30
Okay.
minutes. At least
Oh,
one topic.
okay.
We will focus on one topic and we'll make some progress. Then meeting just
Okay.
twice or not meeting at all.
Right.
Then there's a lot of vacuum in
Right.
out there.
Yeah. Mondays I'm completely free.
Okay.
So yeah, and
So
also Saturdays and Sundays I'm free. Just Saturday in the
okay.
morning I have class from 5 to 7 a.m.
Okay.
my time.
Okay.
5, 6,
Okay.
7 a.m. Yeah, that's 9:30,
ठीक है.
10
So,
for you.
okay. All right.
Yeah.
So
Okay.
so if you're free on a Saturday, we could have an extended class session, right? So instead of 90 minutes,
Yeah.
we do 2.5 hours, so that we cover some
Okay.
ground
Right.
also. We'll take breaks. We'll take 10
Yeah,
minute, 15
works.
minute break, go for lunch and all that, and come back and stuff like that, so that we don't
Okay,
feel
works.
like overwhelmed, right? It gets too tiring otherwise.
Right. Okay.
All right. See
Sorry.
you tomorrow then. Let's stay in touch on Telegram and WhatsApp and all that, and fix up a time
Okay.
for tomorrow. All right. Good to go. Thank you very much for today.
Thank you. Bye-bye.